Now, guys, can you hear me now? Now, can you hear me? Am I audible and visible? Okay. Yes. Now, guys, let's move on to the PN junction diode. Let's move on to the PN junction diode. Listen to me very, very, very carefully. Let's move on to the PN junction diode. Okay. See, PN junction diode means you have got a P-type semiconductor over here. You have got an N-type semiconductor over here. Okay, you have got P-type semiconductor. You have got N-type semiconductor. Listen carefully. When P-type, and when it comes to the P-type, we say majority charge carriers are holes. These are the majority charge carriers. And this is the negative fixed ions. Okay, negative fixed ions. Okay. So negative fixed ion means these are the boron negatives. These are the holes. In case of N-type semiconductor, majority charge carriers are electrons. Okay. And these are the phosphorus positive ions. Phosphorus positive. When this P and N-type are joined together, this is called PN junction diode. When P and N-type are joined together, my dear NEET aspirants, listen to me very carefully. We say this electron, it sees that hole is present over here. So this electron transfers to the hole. It transfers over here. It wants to occupy itself into the hole. This electron basically transfers and it wants to occupy itself into the hole. So my dear NEET aspirants, when this electron transfers into the hole, listen to me very carefully. We say, when this electron transfers into this hole, we say now negative comes here, and so here positive charge will occupy because hole will be present here, positive. So basically on this side, positive charge will remain. Onto this side, negative charge will be occupied. So this region which is formed, this is what we call depletion region. This region is what we call the depletion region. And in this depletion region, we say electric field is set up, that is E inside or E induced. Okay. Now, my dear NEET aspirants, we say, in this particular case, diffusion current is produced due to the recombination of electrons and holes. When these electrons and holes recombine over here, so we say electrons are moving, holes are moving, electrons are moving from N to P, holes are moving from P to N. So due to this, my dear NEET aspirants, I would say diffusion current is produced due to the recombination of electrons and holes. And I drift is produced. Okay, I drift is produced in this particular case. Okay, electric field in the depletion region. Okay, which makes the minority charge to move, So my dear NEET aspirants, this due to this depletion region, listen to me very carefully. When it comes to this P-type semiconductor, when it comes to this N-type semiconductor, listen to me very carefully. In case of P-type semiconductor, what is the majority charge carriers? We say these holes. What is the majority charge carriers here? These electrons. So what is the minority over here? Minority over here is electrons. And what is minority over here? Minority over here is holes. We have seen that. So my dear NEET aspirants, we say this electric field is set up in the depletion region. Diffusion current is being produced when electrons and holes recombine. Okay. And I drift is produced due to the electric field in depletion region, which makes the minority charge to move. So basically, due to this electric field, minority charge carriers are also over here. So due to that, drift current is being produced. And after some, and one more important thing, this drift current is from N to P. Okay. This drift current is from N to P. And this diffusion current is from P to N. Why? Because when electron recombines with the hole, so direction of the current is always opposite to the direction of flow of electrons. So this will be I diffusion. And similarly, due to this, minority charge carriers move. So that will be drift current will be produced from INTP. What I'm trying to say is that I diffusion after some time will be equals to I drift. That's it. This is not important. What is important? Important is this forward bias. Listen carefully. Let's suppose you have a PN junction diode. You have a PN junction diode. In this P-type semiconductor, what is the majority charge carriers? Majority charge carriers are holes. In this N-type semiconductor, what is the minority charge carriers? Minority charge carriers are electrons. Okay. Now, this is the depletion region, my dear NEET aspirants over here. An electric field is set up in the depletion region. From this side, it is positive. From this side, it is negative. Okay. Now, when in this particular case, positive, you connect a battery. When positive terminal of the battery is connected to this P side, negative terminal of the battery is connected to N side. In this particular case, this is what we call the forward bias. This is what we call the forward bias. So when positive terminal is connected to P side and negative terminal is connected to N side, we said this is what we call the forward bias. Now, my dear NEET aspirants, in this particular case, this positive terminal will send positive charge over here. Negative terminal will send negative charge over here. Now, this positive terminal, these holes also have got positive charge. It is going to push positive repels. So this negative repels. So it is going to push this positive P side and N side. So my dear NEET aspirants, due to this, depletion region decreases. So we say now, when the depletion region decreases, the electrons of N and holes of P will again start recombining. When this depletion region decreases, again electrons and holes will start recombining. Again electrons and holes start recombining. Okay. And now, my dear NEET aspirants, when electrons and holes start recombining, now these electrons reach over here. These electrons reach over here. Listen to me very carefully. Battery will make these electrons flow to the N side once again. Now see, when positive terminal is connected to P side, negative is connected to N side, this is called a forward bias. Due to this, these electrons will be pushed, these holes will be pushed. Recombination will take place. Now, these electrons, when they come here, they will not stop here. They will move through the battery. Once again, they reach the N side. This is the procedure of current in forward bias. So, battery will make these electrons flow to the N side once again. This is the procedure of current flow in case of forward biasing. So, if you make the graph between current versus potential difference, initially we say graph is this is less resistance, less current, and my dear NEET aspirants, then it keeps on increasing. It keeps on increasing. This current over here, this current over here. Is this clear? This is the graph that you need to remember. And this is the symbol. This is the symbol. This is the symbol of PN junction diode. This is the N side and this is P side. When N side is connected to positive terminal, when P side is connected to positive terminal, N side is connected to negative terminal. This is what we call the forward bias of PN junction diode. Is this clear, guys? Tell me in the chats. Is this clear? This is what we call the forward bias. Okay. Now, one more important thing. When it comes to the reverse bias simply means when negative terminal is connected to this side, when negative terminal is connected to negative side, positive terminal, this is connected to positive side. Okay, this is positive and this is negative. This is what we call the reverse bias. This is what we call the reverse bias. This is what we call the reverse bias. Is that clear, boys and girls? This is what we call the reverse bias. Now, in this particular case, guys, if this is the negative charge occupied here, this is the positive charge occupied here. Positive charge will attract this majority charge carriers, electrons. Negative charge will attract the holes. Here, depletion region increases. Okay, depletion region increases. And in this particular case, guys, we say electric field is set up from where to where? From positive to negative. This is the electric field. And here also, in the depletion region, electric field was already from positive to negative, electric field inside. But when it comes to the forward biasing, In case of forward bias, my dear NEET aspirants, electric field is set up from this is positive, this is negative, from positive to negative, something like this. Okay. Now, so we say here current will not flow. In case of, guys, in case of forward bias, we say for an ideal diode, we say in case of forward bias, the diode behaves like a simple wire because current flows easily from N to P, then it moves but those electrons back to N. And when it comes to reverse bias, in case of reverse bias, current will not flow. Current will not flow. Okay. Now, my dear NEET aspirants, listen to me very carefully. This is the graph of forward bias. This is the graph of forward bias. So what I'm trying to say in this particular case, this is the graph of forward bias. What I'm trying to say is that in case of reverse bias, when you apply the potential, okay, this is the negative potential, when you apply the reverse bias. So we say current in this case is very small, very small. Current in this case is very small. Now, as you keep on, listen to me very carefully, as you keep on increasing the potential difference, this electric field gets stronger, stronger. Now, in the depletion region also, electric field is in the same direction. Now, in the depletion region also, listen to me very carefully. So we say electric field gets stronger, electric field gets stronger. Now, my dear NEET aspirants, listen to me very carefully. Listen to me very carefully. So what happens over here? What happens over here in this particular case? What happens over here? Initially, we consider in case of the reverse bias, current will not flow. So we say here, diode will behave like an open wire. Now, when you keep on increasing the potential difference, now see, here, electric field is in the same direction as the external electric field. We say in the depletion region, electric field keeps on increasing. So after some time, we say bonds will break. So when bonds break, then current starts immediately becoming, current will flow in the large amounts. So then only we say current graph is increasing. So we say initially no current was flowing. As you keep on increasing the electric field, we say then bonds will break, electric current will start flowing by large amounts. Still, the current in the forward reverse bias is very small current in the forward bias because this current is very large, this current is not, this is in microampere. Okay. In short, in nutshell, I would want you guys to remember one thing. Forward bias means when positive terminal of the battery is connected to what? This positive terminal. Okay, positive terminal of the battery is connected to P side. Negative terminal of the battery is connected to N side. Here, current flows easily. Diode behaves like a simple wire. And in case of reverse bias, we say negative terminal is connected to P side. Positive terminal, higher potential is connected to N side. In this particular case, depletion region increases and over there depletion region decreases, current will not flow. So as you keep on increasing the potential difference, bonds will break after some time, then current will flow by large amounts. Still this current is zero comparable to the current in the forward bias. Guys, tell me, is this clear? So here, diode behaves like an open wire. Directly remember, resistance here it is infinite. Directly remember, is this clear to each and every single student? Tell me guys in the chats, is this clear? Is this clear? Oh? In an unbiased PN junction diode, unbiased PN junction diode means this. We say holes diffuse from P to N, electrons diffuse from N to P. No, this is not unbiased. Unbiased this. Holes diffuse from P to N, electrons diffuse from N to P. In an unbiased PN junction diodes, holes diffuse from P region to N region, correct? Because hole concentration in P region is more as compared to N region. Yes, correct. NEET 2020. The increase in the width of depletion region in PN junction diode. In which bias? Forward bias, reverse bias only. NEET 2017. Which of the following diode is in the forward bias? Guys, this is P side of semiconductor, this is N side. Okay. Now see, here P side is connected to lower potential, N side is connected to higher potential. This is reverse bias. This here P side, N side. P side is connected to 0, higher potential, N side is connected to lower potential. This is forward bias. This is Pn. Here P is connected to lower potential, N is connected to higher potential. -3 is greater than -4. So this is reverse bias. This is P, this is N. Here P is connected to lower, N is connected to higher. This is also reverse bias. Option B. Okay. These are certain number of questions which you guys are supposed to solve in this particular case. Now tell me, this is the positive terminal of the battery, this is the negative terminal of the battery. Okay. Now tell me, you guys are supposed to tell me what is the current in the circuit. Listen, it is like this. This is 5-volt battery, this is D1, this is D2. And this is 10 ohms, this is 20 ohms. This is 10 ohms and this is 20 ohms. Take a look. See guys, it is simple, bro. It is simple, bro. See, this is N side, this is P side. This is P side, this is N side. N side is connected to this higher potential. P side is connected to this lower potential. So in this particular case, this is reverse bias. So if it is reverse bias, this is open bias. So remove this. And this is in forward bias, so it will behave like a simple bias. So this is 10 ohm. This is 5 volts. 5 volts, this is 10 ohms. We have to find the current. I is equal to V divided by R. V is 5 divided by 10. That is 0.5, 1 by 2. 1 by 2. Simple, bro. Which of the diode is in the forward bias condition? This is PN. This is PN. This is PN. This is PN. Forward bias. This is connected to 0. This is connected to -2. This is forward bias. Because when P is connected to higher potential, D is connected to N is connected to lower potential. P is connected to lower, N is connected to higher. Reverse bias. Reverse bias. Reverse bias. Guys, are you able to understand these questions? Okay. This question, NEET 2016, I would want you guys to do this from your end. Okay. The current flow through the resistor R1. What is the current flow through the resistor R1? Guys, see, this is the positive terminal is connected to this N side. This is P side. This will be in the reverse bias condition. This is P, this is N, this is in the forward bias condition. Remove this. Reverse bias. So in this particular case, this is the battery. This is the resistance. This is resistance because this will behave like a simple wire. Simple wire. So this is 2 ohms. This is 2 ohms. This is 10 volts. Now tell me what is the current? V divided by R. V is 10. Resistance 2 plus 2 is 4. 10 by 4, that is 2.5. Okay. Now comes the Boolean algebra. Now comes the Boolean algebra. There is one more question. This I'm giving you as homework. Now comes the Boolean algebra. Now guys, take a look. When it comes to the Boolean algebra, I would want you guys to understand this particular thing. Boolean algebra. Listen carefully. We have a device. There is a device, and this device takes certain inputs. It takes input. There is a device which takes certain inputs and it produces the output. There is a device which takes certain inputs and it produces the output. Now, let's suppose this device, let's suppose its job is to do addition. So if we provide it A, if we provide it B, it is going to provide us A plus B because its job is to do addition. That's a device. Now, this input and this output, this is what we call the digital signal. This digital signal, my dear NEET aspirants, it can be in the form of either 0 or it can be in the form of 1. This digital signal can be in the form of either 0 or we say 1. 0 also means, my dear NEET aspirants, 0 volts. 1 also means, my dear NEET aspirants, 5 volts. 0 also means low. High, 5 also means high. 1 also means high. This means off. This means on. This is the meaning. Now see, addition. First of all, we'll do the addition over here. We'll do the addition over here. Okay, first of all, we'll do the addition over here. Now, in Boolean algebra, you have only 0 and 1. So here you have 3 things that you do: addition, multiplication, and inverse. Let's suppose you have 0 plus 0. Low plus low, it is always going to give you low. Low plus low is low. You have 0, you have 1. Low plus high is always high. You have 1, you have 1. High plus high is always high. Okay. You have A plus 0. Sir, A plus 0, let me tell you. A can be either, we say A plus 0. A can be either 0 or it can be 1. If you put it 0 plus 0, it will be 0. If you put 1, 1 plus 0, it will be 1. So answer is both 0 and 1. That's why we are mentioning A plus A is A. A can be either 0 or 1. Okay, let's talk about this. A plus 1 is 1. Listen, A plus 1. A can be either 0 or 1. Let's put 0. 0 plus 1 is 1. Let's put this A as 1. 1 plus 1. 1 plus 1 is 1. In both the cases, answer is 1. That's why we are mentioning 1 over here. Okay. Now, inverse. Let's suppose you have got 1. Inverse of 1 is 0. Opposite of 1 is 0. 0. Opposite of 0 is 1. Okay. Inverse of 0 is 1. Let's suppose you have A bar. A bar, its inverse of A bar inverse is a reverse of A. A double bar means A because 2 bars cancel each other. Now see, if I say A plus A bar, it will be 1. You can solve it accordingly. Low into low is low. Low into high is high. High into high is high. A into 0 is 0. See how? A into 0. A dot 0. A can be 0. 0 into 0 is equal to 0. A can be 1. 1 into 0 is equal to 0. In both the cases, answer is coming out to be 0. That's why I'm mentioning 0. A into 1 in this particular case is A. A into A bar is 0. These are the things which you guys are supposed to remember. These are the things which you guys are supposed to remember. These are the things which you guys are supposed to remember. Now, De Morgan's law. What does De Morgan's law actually say? De Morgan's law says that A plus B whole bar. If you want to break this bar actually, you can say A bar into B bar. A bar into B bar. Basically, if you want to break this bar, this addition sign changes to the multiplication. Similarly, if it is A into B whole bar, if you want to break this bar, you can write it A bar plus B bar. Commutative law. It is A plus B is equal to B plus A. Okay. Associative law. A into B plus C, bracket is here, is equal to A plus B plus C. Distributive law. A into B plus C is equal to A into B plus A into C. This multiplied by this multiplied by this. Basic simple laws. Okay. Gates. Types of gates. Types of gates. Types of gates. Types of gates. Take a look. We say there are fundamentally there are 3 gates: NOT, OR, and. Okay. Then you have universal gates. Universal gate is NAND and NOR. Okay. Now see. Let's first talk about NOT gate. When it comes to the NOT gate, this is the symbol of NOT gate. What is the job of NOT gate? Its job is to do inverse. Like if you give input as A, output will be A bar, inverse of A. So it's Boolean expression y is equal to A bar. This is output. Truth table. Truth table is the relation between input and output. Let's suppose if you give the input as A, it will give you the output as A bar. If you give the input as 0, it will give you the output as 1. If you give the input as 1, it will give you the output as 0. Because 1 bar is 0. 1 bar is 0. Inverse of 1 is 0. Okay? Yes. Electrical equivalent circuit of NOT gate. This circuit exactly behaves like NOT gate. Let me show you how. See. You have got over here bulb key. This is bulb. Let me show you how. See guys, this is a key. Let's suppose, my dear NEET aspirants, key means input. This is input and this is output. Let's suppose if you keep the key on means 1. On means 1. In that particular case, this battery will send the current. Current always flow in a loop. So current has two paths. Current can either flow through this path or it can flow through this path. But current will always choose to prefer to flow through that path in which there is less resistance. So current will prefer this path because there is no resistance here. So here you have got resistance of the bulb. Bulb is a resistance. So current will choose this path. If current chooses this path, no current will enter the bulb. So bulb will remain off. Off means 0. Now, if you keep this open, now current cannot flow through this because this is open wire over here. Current has to flow through this. So if you keep the key off means open, then bulb will remain on. Now, see, this truth table is exactly this now. That's why we say this circuit exactly behaves like NOT gate. This circuit exactly behaves like NOT gate. Then you have OR. This is the symbol of OR gate. And what is the work? A is input, B is input. Its job is to do addition, A plus B. Okay, this is the Boolean expression A plus B. Now, if I say A and B are the two inputs, what is the output? 0, 0. Input. 0 plus 0 is 0. If you have 1, 0, if you have 1, 0, 1 plus 0 is 1. If you have 0, 1, 0 plus 1 is 1. If you have 1, 1, 1 plus 1 is 1. 1 plus 1 is 1. Okay. In this particular case, you can clearly see over here, output is low when both the inputs are low. This is important. Output is low when both the inputs are low. When both the inputs are low. Okay. And output is high. 1, 1, 1. When any of the two inputs is high, here it is high, here this is high, here both are high. Output is high. When both the inputs are high. Output is high when any of, not both, when any of the two inputs are high. Electrical equivalent circuit of OR gate. Listen carefully. This is electrical equivalent circuit. Let's suppose, my dear NEET aspirants, listen carefully. Let's suppose, my dear NEET aspirants, you are keeping this off, this off. Off means it is open, So current will come. Can it flow through this path? No. Can it flow through this path? No. It cannot reach the bulb. Bulb will remain off. Off, off, off. Okay. Let's suppose if you keep this on, now current can flow through this path. This is on, another is off, bulb is on. Let's suppose you keep this as off and you keep this on. Now current can flow through this path, bulb remains on. Now if both are on, current can flow through both, bulb remains on. Now see, output is low when both the inputs are low. Okay, see, matching. Output is low when both the inputs are low. Output is high when any of the two inputs is high. Output is high when any of the two inputs is high. Oh, sir, amazing. So this circuit exactly behaves like OR gate, AND gate. Let's talk about AND gate. AND gate, this is a symbol of AND gate. Its job is to do multiplication. Now AB, this is output. Y is 0 into 0 is 0. 0 into 1 is 0. 1 into 0 is 0. 1 into 1 is 1. Okay. Electrical circuit, equivalent circuit of AND gate. This circuit behaves like AND gate. Let's suppose this is off, this is off. So current cannot flow. Off, off, off. This will remain on. Let's suppose this is on, this is off. Can the current flow through this one? No, bulb remains off. Okay, one more important thing I just want to tell you over here. What is that? Output is high when both the inputs are high. Output is high when both inputs are high. Okay. Output is low when any of the two inputs is low. Here this is low, low, low. Output is low when any of the two inputs is low. Now see, this is on, connected, this is off, still bulb will not glow. Still bulb will not glow because it cannot reach, the current cannot reach the bulb. Okay. Yes. Yes. Okay. Now, my dear NEET aspirants, take a look. Take a look, boys and girls. We say if first one is off, this is off. So current cannot flow, bulb remains off. If both are on, this is on, bulb remains on. Now see, output is high when both the inputs are high. Output is high when both the inputs are high. Output is low when any of the two inputs is low. Output is low when any of the two inputs is low. That's why we say this circuit exactly matches with AND gate. Then we say NOR gate. NOR gate, when we say NOR gate, NOR simply means it is not plus OR. When NOR plus OR is joined, or we can say OR plus NOT, it forms NOR gate. Now see, this is OR. This is the input A, this is input B. This is OR. What is the job of this OR? Its job is to do addition A plus B. Its job is to do addition A plus B. Now, this output of OR further goes into NOT. So the job of NOT is to put the inverse. So it will put the inverse. So this is the final output. So you can directly make the circuit symbol something like this. This you'll be making here. Instead of this NOT, you'll be putting just the ball. That's it. This is the symbol. And this is the Boolean expression. Y is equal to A plus B bar. Y is equal to A plus B bar. You can make the truth table also. This is A, B. Final output is A plus B bar. What is 0 plus 0? 0. 0 bar is 1. What is 0 plus 1 is 1. 1 bar is 0. 1 plus 0 is 1. 1 bar is 0. 1 plus 1 is 1. 1 bar is 0. Now see, output is high when both the inputs are low. Output is high when both the inputs are low. Inputs are low. Output is low, 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 when any of the two inputs is high. Output is low when any of the two inputs is low. Output is low when any of the two inputs is low. Okay. Now, this is the electrical circuit, equivalent circuit of NOR gate. Now see, in this particular case, this is the battery. Okay. Now guys, if you keep this off, so current will go, this remains off, current can still flow through this path, bulb will remain on. Okay. Let's suppose if you keep this as on, now current will prefer this less resistance path, bulb remains off. Let's suppose if you keep this as on, current will choose this path, bulb remains off. If you keep both on, still bulb remains off. Okay. Okay. Yes. Now tell me, in this particular case, output is high when both the inputs are low. Output is low when any of the two inputs is high. Or if this is off, this is on, bulb remains in that particular case off. Now see, output is low if any of the two inputs is high. Matching, exactly matching. Oh, are you able to understand? Tell me in the chats. Is this clear? Now guys, take a look. NAND gate. NAND simply means AND plus NOT. This is what we call NAND. Okay. Now guys, take a look. This is AND, this is NOT. So AND, when basically A and B goes, what is the job of AND? Its job is to do the multiplication. Then whatever is the output of AND, that goes as input of NOT. It will put the bar. This is the final output. So it's direct. This is the symbol of NAND. This is the symbol of NAND. So Y is equal to AB bar. This is the Boolean expression. So my dear NEET aspirants, I can say 0, 0, 0, 1, 1, 0, 1, 1. Now see, this is 0 into 0 is 0. 0 bar is 1. 0 into 1 is 0. 0 bar is 1. 1 into 0 is 0. 0 bar is 1. 1 into 1 is 1. 1 bar is 0. Okay. Yes. Now see. This gate exactly behaves like NAND gate. Let me show you how. See, you have got K1, you have got K2, you have got bulb. These are the two inputs. This is output. Let's suppose if you keep this on, this is on, both are on. If this is on, current will choose this path. So bulb remains off. Let's suppose if this is on, this is off. This is on, this is off. Current cannot flow through this path. Current has to flow through this path. Bulb remains on. Now, if this is off, this is on. Off, this is on. Still, current cannot flow through this path. Current has to flow through this path. So bulb remains on. Okay. If this is off, this is off. Both are off. In that case, bulb remains on. Now see, if you check over here, output is high. See, output is low when both the inputs are high. Output is low. These statements are very important. When both the inputs are high. And output is high when any of the two inputs is low. Output is high when any of the two inputs is low. When any of the two inputs is low. Okay. That's great. Now take a look, boys and girls, over here. What is the output in the following circuit? What is the output in the following circuit when all the three inputs A, B, and C are first 0, then 1? If you put this 0, 0, 0, what is the final output? This is AND. Its job is to do multiplication. 0 into 0 is 0. Now this 0 will go over here. This is NAND. What is the final output of NAND? That is AB bar. So now 0 into 0 will go over here. 0 into 0 is 0. Now 0 bar is 1. So when first output is 0, it is 1. Now put the value of input as 1. 1, 1, 1. 1 into 1 is 1. 1 into 1 is 1. 1 into 1 is 1. 1 bar is 0. Then it comes out to be 0. 1, 0. This circuit. Can you see this circuit, guys? Can you see this circuit? Is this circuit visible? Yes, this is visible. Now take a look. See, you have to tell me in this particular case, what? Which circuit is this actually? Listen to me very carefully. This is K1, this is K2. K1, K2, and this is bulb. Now see, guys. Let's suppose you keep this K1 on, you keep this on. This is higher potential, this is lower potential. Current always flow from higher to lower. If this is on, don't you think that current will prefer this path? It will not flow through the LED. This remains off. Now, if this is on, this is off. So current can flow through this, but it cannot flow through this. So current has to flow through LED. So this remains on. Now, if this is off, this is on. This is off, this is on. Still, current cannot flow through this path. Bulb will remain on. Current has flow through bulb. If this is off, this is off. Both are off. In that case, current has to flow through this LED. Now tell me. Now see, how do you solve this question? Output is low when both the inputs are high. And output is high when any of the two inputs is low. Okay. Output is low when both the inputs are high. Output is low when both the inputs are high. And output is high when any of the two inputs is low. So it is a NAND gate. It is a NAND. Are you able to understand now? This one. This I'll give you as homework now. Answer in this case is NOR. Make the truth table, then compare the truth table. This is key 1, this is key 2. This will be LED. This is plus 6 volt. This is 0. Current has to flow from this plus 6 to this 0. Okay, take a look. In the combination of the following gates, the output Y can be written in terms of A and B. Now see, this is A and this is B. Now see, the same A goes here, the same B goes here. Now when this B passes through the NOT gate, it will do the inverse B bar. This will become the A bar. This makes it as A bar. Now this is OR. This is also OR. What is the job of OR? To multiply. So it will be AB bar. This multiplied by this. This will be A bar B. This is AND. What is the job of AND? To add. So now this and this will go input over here. So basically final output will be this input AB bar plus this, that is A bar B. We are done with this also. We're done with the semiconductors, huh? How many of you have joined this class 10 a.m. in the morning? How many of you joined this class at 10 a.m. in the morning? Tell me. That's great. That's great, ladies and gentlemen. Okay. Now, guys, we have got ray optics. Guys, can we complete this in the next class? Because I am also too tired. Okay, one class of 1 hour I'll be taking tomorrow, or 2 hours. What do you guys say? What do you guys say? Hmm? Yeah, remaining 11th class chapters plus this optics. Let's do it in one go, like 2 to 4 hours. Okay. Yeah. So that's all for today, my dear NEET aspirants. Thank you so much. Take care and bye bye. Okay, you guys can leave, huh? See you guys tomorrow.